ASC Study Questions 1-1. Question 1. Somebody did a transmission service and they put the wrong fluid in. They put in a high friction modified fluid instead of a highly friction modified fluid. Technician A says that the transmission is going to slip. He's not right. Technician B says that a shudder or harsher than normal shifts could occur. That guy's correct. The reason is, with more friction modifier being added to the fluid, it's going to actually slip better with a lower coefficient of friction before full pressure is applied to the clutches and the steels or to the band. So what they're saying is that this transmission was designed to have a pretty slippery fluid, and it got a more grippy fluid. So when the transmission goes to apply a clutch or a band, it's expecting that light pressure that's there to let the clutches and steels slip past each other. But because that fluid is got a higher coefficient of friction, it's going to grab much sooner than it was designed to. So as far as friction modifiers, you can go to this website here. It's Machinery Lubrication. It'll be in the PDF, but it's up there on the top if you want to type that out. And it actually talks about friction modifiers and goes into a little bit more detail than what we're going to do here. But it's the idea is that the higher the friction modifier, the slipperier the fluid is under light pressure. It doesn't cause it to slip when it's applied. It's just a higher slipperiness when the transmission is applying the clutch, not when it is fully applied. Question 2, pan's being removed from the transmission and they found non-metallic material in the pan. Technician A says it's normal to have some of that friction material in the pan. He's correct. Technician B says that the transmission should be disassembled to find the exact location where it's occurred. Well, a little bit of material in the pan is okay. So I'll let you read below, but I'm going to go ahead and skip over to the pictures where this is not okay. So we have the corner of a transmission where there's a magnet, it's a round magnet, and you can see it's covered in, metal pieces. And those metal pieces have come from somewhere. Metal is not good. Metal means this transmission has a problem. So the next picture here shows a normal amount of sludge in the bottom, or sediment. That there is mostly clutch material. And along with clutch material is going to be some metal. It's going to come from the steel plates, and it could come from the gears and the bearings inside the transmission from normal wear. But that transmission and what they're finding on their finger there in the picture is really not that bad. So it's cleaned it out, put a new filter on, put new fluid in. Our next picture, this is probably the source of the metal from the first picture with the magnet and the metal on it. You can see in the picture where we have heavy damage on the sun gear. And if you've got heavy damage on the sun gear, you're going to have heavy damage on the pinions. So you can't just wipe out that first picture's transmission pan and call it good. So you need to make sure that if you find large amounts of metal in there, if that customer's in there just for a transmission fluid service, that's probably not the only reason why they're there. They're probably there to fix a problem that they're not telling you about. So you need to talk to the customer, talk to the service writer or your foreman or your shop manager, and get them as early as possible, because if you put fluid in this thing, there's a good chance it's not going to work when you're done with it. So question 3, 2 technicians are discussing the adjustment of a band. Now this is on a transmission with an externally adjustable band. Remember in class we talked about in the old days of the 80s and earlier where transmissions were actually designed to have external band adjustments because that was something that you did as a maintenance item. So here in the slide I've got the general steps to the process. Step 1, first you're going to loosen the lock nut on the band adjustment bolt. And then you're going to tighten the screw to about 10 foot-pounds, and it's going to be specified in the workshop manual. Step 3, you're going to loosen that screw that you just tightened to 10 foot-pounds. You're going to back it out 2 full turns. And while holding that screw at that position, you're going to tighten its lock nut back down to the case to about 25 foot-pounds. And the amount of screw tightening to foot-pounds or inch-pounds is specified in the workshop manual, and how many turns to back it out is going to be specified in the workshop manual also. So here in this image, I have a drawing, and it's not exactly what we're talking about here, but if you can imagine that this rod that's actually pressed into this case, this kind of brown looking aluminum case over here, it's going down and it's pushing against the band, and the band is this black line that's going all the way around over to the servo. If we could adjust the position of this band in and out by threading it on this end and letting it stick through the case, we could put a lock nut on it. So the 10 foot-pounds actually causes this band to lock up onto the drum. And that sets it to a preset tension. From there, you go to your next step, which is going to involve taking this adjustment screw and backing it out of the case. So you're actually going to unscrew it from the case to where this band will actually become loose inside the case around the drum, because you don't want it applied all the time. You don't want to leave it at 10 foot-pounds, because that band is going to be held stationary, or the drum is going to be held stationary. So question 4, when checking for excessive voltage drop with the battery ground connection, what meter selection should be used? Well, that's basic electrical. And if you're working on a car and you're working on something that gets turned off and on, a solenoid or a light bulb or an electric motor, if you need to check for voltage drop, you better have that thing on DC volts. So this picture here is out of the textbook, and it shows various steps of testing a starter motor circuit, where the DVOM here on the top left has the positive lead at the positive battery, and its negative lead is going around the positive cable of the starter motor. So when you go to turn the key, that current's got to flow through there, and you're going to see how much voltage is dropped through it. And normally on low amperage circuits, which is not this one here in the picture, you shouldn't lose any more than about 0.2 volts. And that's one of those ASE questions that you're going to see a couple times, not just in electrical, but you're going to see it elsewhere in the testing. So, question 5. Technician A says that the manual linkage may get out of adjustment if an engine or transmission mount were to fail or collapse. Technician B says that the shift selector should be adjusted so it matches the manual valve T10s. Now, these two guys could be talking about two different systems. So let's go ahead and break it down that way. The first system is going to be on an older vehicle that's not going to use a cable or any electronic shifting mechanism. It's actually going to have linkages, which are going to be threaded bars with ball joints or clevis joints on the ends of them that connect the shifter, which is mounted in the body, down to the engine and transmission, which is mounted on the frame. So if the engine is allowed to move up and down, that linkage, which is stationary on the body, will get motion if the transmission or the engine mount is allowed the transmission or motor mount or transmission or motor to move up and down. And if it does that, you could get some weird symptoms. So whenever I accelerate, the transmission goes into neutral. Or whenever I, floor it and go to wide open throttle, the transmission doesn't downshift when I'm going slow or going about 30 miles an hour, because maybe it goes down into manual third or manual second. So technician B is talking about the Prindle, the park reverse neutral drive low indicator on the dashboard. If it's right at the shifter, or maybe it's up on the instrument panel, that the shifter's location or position must correlate perfectly with that indicator. If it doesn't, then you might have a customer sitting in a car and they put their transmission in neutral for some reason, and it goes into drive. So they get out of the vehicle and the car takes off. Or maybe they try to put it in park and it doesn't go to park, and maybe it's out of alignment. I've seen customers that would believe the park reverse neutral drive indicator before they would believe how the shifter felt. For us, park is all the way up or all the way forward with the shift lever. For them, it was, I need to see that little orange needle go over the P. And if it was out of adjustment, in this case, the transmission would be in reverse. So they had the vehicle towed to the dealership for that reason. And come to find out, somebody had done some work under the dash and they did not readjust the little cable that goes from the shifter up to the park reverse neutral drive low indicator. So the best way to line those up is to actually put the transmission in neutral and then adjust the indicator needle to the neutral position. Because if there's any error from that center position, it will be slightly out all the way to the left, which would be the park side, or slightly out all the way to the right, which would be your low gear side. So here in the picture, we kind of show some of the indicators. So on the manual valve, the green valve here on the right, it's showing park reverse neutral, drive 4, drive 3, drive 2, drive 1. And then we have this thing right here, which is called the rooster comb. Whenever you put a transmission into gear, it snaps into that position automatically because of the mechanism inside the transmission. And you should remember that because the 4L60s all had a rooster comb in them. But these positions here, those notches inside the transmission, need to match the park reverse neutral drive low indicator on the dashboard. So the technician A talking about the linkage. So here we have the underside of a transmission. And this, let me get a pen here. This right here is the mechanism or the lever that goes into the transmission to put the transmission into the various gears. This lever or this linkage goes up to, and it actually connects to the bottom of the steering column on this vehicle. This is an old Chevy vehicle, probably a truck. I don't know. Doesn't matter? No. And if this transmission, because this is the side of the transmission, we're looking up, here's the oil filter, there's the back of the block. Okay, here's the back of the block and it goes around. And if that were allowed to lift up, or maybe the other side lifts up or drops down, this end of the shaft isn't going to move. But this end right here, relative to the transmission, is going to move up and down depending on, the action or the failure of the motor mount or the transmission mount. So they have to be, the motor mounts and transmission mounts have to be in good shape, especially if you have a linkage system like this. Okay, Technician 6. The method shown is the correct way to remove a transmission pan. If you've never removed an automatic transmission pan, well, I hope one day you get to. So Technician B says that all the pan bolts should be removed first and drop the pan straight down to avoid the possibility of spilling ATF. In most cases, the transmission pan is not the only place where the fluid sits. When the engine's off, the transmission pan is usually overfilled by fluid that is drained down from the transmission. So when taking the transmission pan off, it's best to take off the bolt on 3 sides of the pan if it's a square pan. And what that's going to do is then let that pan drop down a little bit, and hopefully that part that drops down is going to pour into a drain pan or drain bucket that you have waiting. Then the remaining line of bolts, you start to take those loose with the last one there. One hand on the pan, one hand on your impact. You zip the bolt out and you drop down the transmission pan and set it down into the drain pan so you can make as little of a mess as possible. Here in the picture, you see this transmission pan. where it's actually it's draining out the bottom side of the pan here, and you see all the fluid coming out. The bolts up here on the top line are still in, so they've broken all the bolts loose and they've taken out on 3 sides, and that allows the pan to drop down and allows the fluid to pour out. Now, the reason we have to do this way in most cases is because most transmission pans don't have drain plugs. If you got a drain plug, then great. Take that dude out, drain as much as you can out, then take the pan off and do whatever service you need to do inside it. Question 7 says that the filter shown should be replaced rather than cleaned whenever the transmission or transaxle is being serviced. Technician B says that the filter should be soaked in ATF before being installed. A is the correct one. Transmission filters are not that expensive, so if you're doing a major service or a maintenance, replace it. Don't try to flush it out. It does you no good. We saw the prices for some of these filters. The 4L60 had filters of about $3. So why not just replace the filter? Technician B is talking about soaking the filter in ATF. That's something you're going to do with clutches and bands. They really need to be soaked for a number of hours before they are operated inside the transmission, but not the filter. Because when you fill the transmission, the filter is going to be submerged in the fluid. So you don't need to do that. So on this first picture right here, this is an older Chrysler filter. And notice it's a mesh type filter. It's actually woven or maybe non-woven, but it's a mesh type filter. So if you have a paper element or a mesh type filter like this, you can't flush everything out of them. There's no possible and no cost-effective way for you to do that. So why not spend the $5 or $6 for a new filter, especially if you're putting your name on this transmission. However, if you go back old enough, let me come back to that picture. If you go back to an old enough transmission, notice this transmission filter, if you go follow on the inside of my line here, on the inside of that line is actually a mesh metal screen. And in this case, you could flush it out. And I say could because they're cheap, replace it. So, this is an instance where the filter could be, flushed out, but only if it's a metal screen filter. So back to the previous picture. This shows the transmission filter in place. This is the mesh filter that was in the first picture. This is on a Chrysler transmission. And see how it's bolted in. It's got 3 bolts that go through the filter that hold it up to the valve body. And, if you're doing a service, replace it, okay? It just makes no sense to try and keep it. Question 8, transmission transaxles being filled with fluid after a replacement, fluid and filter replacement. Technician A says that the factory specifies the amount you need to put into it. So if they say that Dodge 1500 transmission takes 13 quarts, you need to pour 13 quarts back in it. Technician B is saying to use the exact fluid. Well, that guy is correct. That's one of those questions that you're going to see a couple times. Should I use the right fluid or should I use this other fluid? Well, the right fluid is always the right answer. Technician A, back to him. You cannot, during a flush, or say not a flush, you cannot during a filter and fluid exchange, remove all the fluid from the transmission. Just like on an engine, if you were to remove the drain plug on an engine, it would drip for a very long time. Put the plug back in, take it out, it'd have more fluid come out. And it's even more so on an automatic transmission because it has more internal hydraulic cavities, which would be accumulators, the torque converter, the fluid lines, the hydraulic circuits, the valve body, the clutches, the band servos, they're all going to hold fluid. So if that transmission is specified to hold 13 quarts and you can't drain the torque converter, you're probably only going to change out about maybe 8 to 10 quarts, and it just depends on how it drains out. So general directions here: before starting the vehicle, if you've drained the fluid, you need to pour in about 1/3 of the capacity of the transmission. So if it takes 12 quarts, you're going to put in about 4 quarts. Then you're going to start the vehicle. And very shortly after starting the vehicle, you're going to start to pour in an additional 1/3 of the capacity. So you're going to go from 4 quarts and work your way up to about 8 quarts. Okay, maybe even before then, you're going to go down to step 4 and you're going to start pulling that dipstick out. Is the transmission fluid level on the stick? Okay, no, add more fluid. Okay, it's on the stick now, so I'm going to add maybe not a full quart, but maybe a half a quart until it gets up into the range. So here we've got a transmission, dipstick. There you go. There's the old GM style. And we have the dipstick here. We obviously want the fluid to be within this range here, okay? But that also is only when it's hot. And transmission fluid is going to expand when it's hot. So when you're filling the fluid up, after starting it, you put in the 4 quarts, then you start it. It should not be on the dipstick. So you're going to start to put in your 5th quart, your 6th quart, your 7th quart, and it might start to show up on the dipstick. So from here, and it depends on the transmission, to probably about here might be a quart, and then from here to about here might be a quart. But from here to here might be a quart, because the valve body and the filter and other pieces hanging down inside the pan will start to take up the space of the fluid. So the closer you get to that hash mark right there with the fluid, you don't want to start and keep adding 1 quart. You want to knock it down to about a half a quart until you slowly work yourself into the perfect range right here on the dipstick. And then you're good to go after that. You shift it into the gears, you recheck it, you put it on the floor, you go drive the vehicle, you come back, and you check the fluid again. So technician A for question number 9 says that this style of transmission or transaxle pan uses room temperature vulcanizing RTV sealant, silicone, and not a gasket. Technician B says that the contact adhesive can be applied to hold the gasket in place. All right, so there's an ASE answer, and then there's my answer on this one. So let's go to the picture real quick. So notice this is a 4L60 pan, and if we can look at it, or if you could remember, around the bolt holes, the metal of the pan is actually raised towards us, and then there's a raised rib that connects all these bolt hole rims. And in this section here, in this section here, the pan is actually lower, so that creates a ridge. Whenever you see a ridge like that, that usually means there's going to be a gasket there. The other thing is that you could also, what came off of this transmission? If it's ever not been serviced before, it's got the factory gasket or gasket material, then, you can go from there. But if you look at the pan, it will tell you what type of fluid or what type of filter gasket to use. All right, so on to the next picture. Now, this isn't necessarily a transmission pan, but what it is, it's an engine pan, and instead of having a raised ridge, notice these are valleys that are pressed into the pan. And usually what valleys indicate is that this transmission or whatever this cover goes on to, it's a EJ25 oil pan, is going to use RTV silicone. And the reason it has the lower section is that so that the RTV can be laid on the inside of it. The RTV will extrude into the groove and create a really good sealing surface or sealing flange. So this one here, gasket, because it's raised. This one here, instead of having a raised section, it's actually depressed through here. You're going to actually use RTV on this one. Question number 10. So what is the usual method to tighten the retaining bolts for a pan on an automatic transmission or transaxle? Well, all of them were correct. You obviously, in a perfect world, especially as greenhorns to the business, are going to start these bolts by hand. Because it's oftentimes that these things are going to be 6mm bolts by 1.0 threads, or maybe they're 7 or even 8mm bolts, which are kind of big for that case. And it's very easily cross-threaded, and that is the last thing you want to do, because that's more than likely probably going to happen during a transmission service that you're performing, and the customer's waiting in the waiting lounge. So start the bolt by hand. Wait until you get really good at it before you start loading them up in the impact and zipping them in. And if it starts to cross thread, stop. Okay, stop as soon as possible. Back the bolt out. Move that bolt to another hole. Make sure it screws in properly, and then use a fresh bolt, because even aluminum will damage threads on a steel bolt. So gradually tightening the bolts around the pan, kind of the same concept as putting on a wheel. You're not going to throw a wheel up there, run one lug nut all the way down, and torque it before you go to the second one and put it on. You're going to go around the pan and try and work it down to the final torque. And the last one, torque wrenches, that's the tool you have to have. Because if somebody comes up and let's say they claim that you've done something wrong or you caused damage, and it might encompass the use of a torque wrench. Well, if you know how to properly use a torque wrench, and you have a good torque wrench, one that is reliable, then their argument could be null at that point. They're saying that, he didn't use a torque wrench. I'm like, no, I always use it, because everybody in the shop sees you use it. And it is a good habit on things that really matter, things that might leak, things that control fluid flow, like in the valve body. Those are the things that you really should be careful with on the torquing. Definitely don't under torque, and absolutely do not over torque, because that could make things 10 times worse, leaking or even damage, because you pull the threads out. And then the last one right there, that is definitely not how we torque. I mean, that's not me, because he has way more hair than me on his head. But if you think about it, this is actually a really dumb way to torque, because he's pulling up. And when he pulls up, he's using his back muscles and his back. Whenever you're torquing, especially on wheels, push down on the torque wrench. It will torque just fine in that direction. The end. See you next time.